Hello, Algebra 1. We are going to do your Chapter 2 study guide for your test coming up. So let's get into it. Okay, so we are starting with just solving equations. So when we are solving equations, if you like to keep that line down the center, then definitely keep that line down the center. Remember, for all of these, we're solving our equations for x. So that means we are trying to get x by itself. The first thing we always want to undo is addition or subtraction. So I am going to add 18 to both sides of the equation. This is the negative 18, so the opposite is plus. So that's why we add 18 to both sides. And I get that x to come down. Negative 18 plus 18 is 0, which is what we want, equals negative 34 plus 18. I need to do that in the calculator. That gets me negative 16. And so x equals negative 16. Remember with that one, okay, so negative 34 plus 18, like I said, I just plugged that into my calculator. I think it's easier. I don't know. Why not if you have it? So when we do that, that would be negative 34 plus 18, and that gets me that negative 16. Okay, let's move on to number 2. So 2, again, we're solving. So I'm going to put my line down the center. You don't need to if you don't want to. I first always, I want to move my constants to the other side of the equation. So I'm going to do that by subtracting 7 from both sides. So my 2x comes down. 2x equals negative 7, or plus 7 minus 7 is 0. And then negative 1 minus 7 is negative 8. And then we still need to get x by itself. That 2 is being multiplied 2 times x. So to undo that 2, undo the multiplication, we divide both sides by 2. Negative 8 divided by 2 gets me negative 4. 2 divided by 2 gets me 1, which is what I want. X equals negative 4, which is my solution. Okay, let's move on to 3. So for number 3, a lot of these are all the same. We are just putting a line down the center. I want to first undo anything that's being added or subtracted. We have a positive 17 on the same side of the x, so the opposite of adding is subtracting. And that gets me negative x. 17 minus 17 is 0, which cancels, and 20 minus 17 is 3. Now, that negative x is not all by itself. It has that negative 1 attached to it, and we want it only attached to a 1. So what we need to do, it's negative 1 times x. So we need to, again, use inverse operations to undo that negative sign. So I'm going to divide both sides by negative 1. Negative 1 divided by negative 1 gets me that positive 1, which is what I want. So I get x equals 3 divided by negative 1, which is negative 3. Okay, kind of amping it up a little bit here. So remember, your first step whenever you're solving these is to distribute. We didn't have anything to distribute in 1 through 3, but we do in 4, so we're going to distribute now. So negative 5 is on the outside of the parentheses, so it needs to distribute to the x and the negative 2. And then remember, this is a negative 1 on the outside of the x and the 2, so we're going to distribute in there as well. If you need to put your line down the center, put your line down the equal sign. So negative 5 times x, so we have negative 5x. Negative 5 times negative 2 is positive 10. Negative 1 times x is negative x, and negative 1 times 2 is negative 2, equals 50. I can then combine any like terms. So do I have any like terms on either side? And I do. Negative 5x minus x. So negative 5x minus x gets me negative 6x. And then 10 minus 2 gets me 8. And now I'm at a problem like I was in number 2. I want to undo whatever's being added or subtracted. So I would subtract 8 from both sides. And I get negative 6x. 8 minus 8 is 0. 50 minus 8 is 42. And then to get x by itself, our final step, negative 6 is being multiplied. So to undo multiplication, we divide both sides by negative 6. And I get x is equal to negative 7. Remember, you guys can always check your work by plugging it back in. If when you simplify, you get 50, then you did it correct. Okay, on to the next one. 3x minus 7x plus 12 equals 2 times x minus 3. First thing, I'm going to draw my line. But first thing I'm going to do here is distribute. We always want to get rid of parentheses on both sides of the equal sign. So I'm going to distribute this negative 1 to the 7x and the 12. I'm not going to combine anything first. We always distribute first. And the 2 to the x minus 3. Okay, so from there, I just rewrite it. So 3x, negative 1 times 7x is negative 7x. Negative 1 times 12 is negative 12, equals 2 times x, which is 2x, and 2 times negative 3, which is negative 6. So from there, I combine like terms on each side of the equal sign. The only like terms I have is 3x minus 7x. 12 can't combine with anything, 2x can't, 6 can't, so we are there. 3x minus 7x is negative 4x. Bring down the minus 12 equals 2x minus 6. Okay, so from there, I want to move my variables to one side of the equation. So I can either move the 4x to the right side or the 2x to the left side. It doesn't matter. I usually like to keep my negatives, I like to keep it positive. So if I have a negative over here, I'm going to add 4x to both sides of the equation. And so negative 4x plus 4x is 0. Negative 12 comes down. 2x plus 4x is 6x, and then negative 6 comes down. If you would have moved it to the other side, you would have still gotten the correct answer, just a different way of doing it. So because I moved my x's to this side of the equation, I need to move my constants to the left side of the equation. So what I'm going to do is I'm going to move this negative 6 to the other side of the equation. I'm going to add 6 to both sides. And I need over here, so negative 12 plus 6 is negative 6 equals, that 6x is going to come down, and negative 6 plus 6 cancels. And then last step, we want to get x all by itself. So to do that, I need to undo this multiplication because it's 6 times x. Divide both sides by 6. And then I get, so negative 6 divided by 6. Well, anything divided by itself is 1, but we have negative 6 divided by 6, so it's negative 1 equals x. So x equals negative 1 is my final answer. Okay, let's move on to 6. So again, start the same. I'm just going to put my line down. You don't have to if you don't want to. And then I am going to start by distributing. only going to distribute on the left side, negative 6 or negative 7 times x and negative 7 times negative 3. So that gets me negative 7x plus 21 equals 11 minus 7x. No like terms on the left, no like terms on the right. So what I'm going to do is I'm going to move my constants to the same side. Doesn't matter which side, so I am just going to add my 7x from here to the other side, but hopefully you're seeing what's about to happen. Well, negative 7 plus 7x is 0. That cancels, and I'm left with just 21 equals 11, and negative 7 plus 7x is 0. So the constants or the variables canceled out, and is that a true or false statement? Well, that's a false statement. So when that's a false statement, because 21 doesn't equal 11, that means there's no solution. So remember, when all the variables cancel out, and you are left with a false statement, it is no solutions. So remember, all that means is that there is no value of x that will make this equation work at all. Okay, let's move on to the next problem. Last solving equations here. So I'm going to put my equal sign down the center. I am going to start by distributing. So I have a minus on this side. So remember, that means I'm going to be distributing a negative 1 to 2x and 7. And then the negative 2, I'm going to be distributing to x and 6. So this negative 6 right now, we don't do anything to it yet. We just bring it down. We can't combine before we distribute. So that means negative 1 times 2x is negative 2x. Negative 1 times 7 is negative 7 equals negative 2x minus 12 minus 1. Now I combine any like terms. So I can combine negative 6 and negative 7. That negative 2x just comes down. And negative 6 minus 7 is negative 13. Equals negative 2x can't combine with anything, but we can combine negative 12 and negative 1. Negative 12 minus 1 is negative 13. Hopefully you're seeing what's happening here. But if not, our next step would be to move the variables to one side of the equation. So I'm going to add 2x from this side and move it to this side. So what happens, negative 2x plus 2x cancels, that negative 13 comes down. Negative 2x plus 2x cancels again, and that negative 13 comes down. So my variables canceled out. Am I left with a true statement or a false statement? I'm left with a true statement. Negative 13 equals negative 13. So when it's a true statement, it's infinitely many solutions, or IMS. So again, when all variables cancel out, and you are left with a true statement. It is infinitely many solutions. So when the variables cancel out and you're left with a true statement, it's infinitely many. When the variables cancel out and you're left with a false statement, it is no solution. Okay, so let's move on to literal equations. It just says solve each equation for the specified variable. Number 8 says solve for y. That means I'm trying to get y all by itself. Really similar to what we were doing in 1 through 7. It's just that we have one extra letter in there. So I always want to undo whatever's being added or subtracted first. So that's my first step. Whatever's being added or subtracted on the same side as the y, that's what I want to move over. The 3x is what's being added. It's a positive 3x. So I'm going to subtract 3x from both sides of the equation. 3x minus 3x cancels. I bring down that minus 9y equals, and then we write this in standard form, negative 3x plus 18, because we want to write the variables first, the constant second. I still need to get y all by itself. So to do that, I undo anything that's being multiplied or divided on this side. The negative 9 is being multiplied, so I'm going to divide both sides, everything through, by negative 9. And that gets me y equals, now a negative and a negative, those become positive. And can I simplify that? 3 and 9, does a number go evenly into both 3 and 9? And it does. 3 goes evenly into both 3 and 9. 3 divided by 3 is 1, and 9 divided by 3 is 3. So 1/3 x, and then 18 divided by negative 9 is negative 2. So my answer is 1/3 x minus 2. Okay, so let's move on to number 9. Again, it's saying solve the equation for y. So that just means we're getting y all by itself. To do that, I'm going to undo anything that's being added or subtracted on the same side as the y. So 6x is being added because it's a positive. There's no sign. When there's no sign, it's plus. So I'm going to subtract 6x from both sides. 6x minus 6x cancels. I bring down that 3y. 12 and negative 6x can't combine. Those aren't like terms, so I just write it as negative 6x plus 12. I still need to get y by itself, so I divide everything by what's being multiplied. It's 3 times y. So I divide here by 3, here by 3, and here by 3. 3 divided by 3 is 1y. Negative 6 divided by 3 is negative 2x. And 12 divided by 3 is 4. So my final answer is negative 2x plus 4. Okay, on to proportions. So for proportions, remember, if you have two fractions that are set equal to each other, we can cross multiply and solve. So all I'm going to do is I'm going to cross multiply x times 20. Remember, it's the top times the opposite bottom. So x times 20 is just 20x. Equals, and then I'm going to multiply 28 by 5. $28 times 5 is 140. And then to solve for x, I just undo. So I have 20 times x. So to undo that multiplication, I'm going to divide everything through by 20. 20 divided by 20 is 1x. And then 140 divided by 20 gets me 7. So x is equal to 7. Okay, let's move on to our next one. So a little bit more complicated, but doesn't change the way that we set it up. So we first multiply 6 times x minus 7, so top times opposite bottom. Equals 2 times its opposite bottom, so 2x minus 5. And then I solve just like if I were solving any multi-step equation from up above. I would start by distributing 6 times x and 6 times negative 7, and 2 times 2x and negative 5. So that gets me 6x, 6 times negative 7 is negative 42. 2 times 2x is 4x, and 2 times negative 5 is negative 10. And now I just start to solve. So I want to get my variables on one side of the equation. I look to see which is bigger, 6 or 4. 6 is bigger, so I'm going to move the 4x. Subtract it. It's a positive 4x, so I subtract 4x from both sides. 6x minus 4x is 2x, and I bring down that negative 42. 4x minus 4x cancels, and then I bring down that negative 10. I keep going. I'm just going to recopy that because I'm running out of room. So I then want to get 2x all by itself, so I move my constants over. I'm going to add 42 to both sides. 2x comes down. Negative 42 plus 42 cancels, and negative 10 plus 42 gets me 32. Last step, undo the multiplication. 2 times x, so we divide both sides by 2, and I get x equals 16. Okay, last proportions question. So I'm going to, again, set it up the same. I'm going to cross multiply. 5 times the opposite bottom, so 5 times 3x plus 6 equals x minus 10 times its opposite bottom, which is 6. And I'm going to distribute. Now, I know this one looks a little different, but it's really not different at all. The 5 gets distributed to the 3x and the 6, and then we can just do it backwards. The 6 times the x and the 6 times the negative 10. So 5 times 3x is 15x, and 5 times 6 is 30, equals 6 times x, which is just 6x, and 6 times negative 10, which is negative 60. Then I move my variables to one side of the equation. I look to see which is bigger, 15 or 6. The 15 is bigger, so I'm going to move my 6x to the other side. 15x minus 6x gets me 9x. Bring down that plus 30 equals 6x minus 6x cancels, and then I bring down that negative 60. We keep going. We want to get the x all by itself, so we want to move the constants to the opposite side. I moved my variables to the left, so I'm going to move my constants to the right. So I'm going to subtract 30 from both sides of the equation. And so I have 9x, 30 minus 30 is 0, equals negative 60 minus 30 is negative 90. Last step is to get x all by itself. To do that, I undo the multiplication. I divide both sides by 9, and I get x equals negative 10. 9 divided by 9 is 1. Negative 90 divided by 9 is negative 10. And that does it for proportions, I think. Yeah. Okay, last page, absolute value equations. That's our last section that we did together. So let's get to it. So remember, with absolute value equations, your first step always is to get the absolute value expression all by itself on one side of the equation. So we're going to do that. We are going to just rearranging stuff. Okay, we are going to get this 2x plus 6 all by itself on one side of the equation. So remember, we don't distribute. That negative 4 does not distribute, but it is being multiplied. So to undo that, we're going to divide both sides by negative 4. And I get the absolute value of 2x plus 6 equals negative 32 divided by negative 4 is positive 8. Now that I've gotten my absolute value expression isolated, now I can split it into my two equations. Remember, the inside of the absolute value doesn't change. 2x plus 6 doesn't change. It's what it equals. It equals the positive 8, and then it equals the negative 8. Remember, if this was equal to a negative, we'd have to stop and make sure that doesn't work. An absolute value always equals a positive number, so that would be no solution. And so now that we've split it into our two equations, we can just solve each equation separately. So I would subtract 6 from both sides, and I get 2x. 6 minus 6 is 0. 8 minus 6 is 2. And then divide both sides by 2, and I get x equals 2 divided by 2, which is 1. And then I do the same thing for my second equation. I subtract 6 from both sides, and I get 2x. 6 minus 6 is 0. Negative 8 minus 6 is negative 14. Divide both sides by 2 to get x all by itself, and I get x equals negative 7. Remember, absolute value expressions should always have two answers. So my answers here are 1 and negative 7. Okay, so let's move on to 14. 14, is the absolute value expression already isolated? It sure is. So we just start by splitting it into 2. 6x minus 3, the inside doesn't change, equals positive 21. And 6x minus 3 equals negative 21. And now I just solve those each separately. So I would add 3 to both sides. I get 6x. Negative 3 plus 3 is 0. 21 plus 3 is 24. Divide both sides by 6. And I get x equals 4. Do the same thing on my second equation. So I would add 3 to both sides. 6x equals negative 18. Negative 21 plus 3 gets me negative 18. Divide both sides by 6. 6 divided by 6 is 1x. And negative 18 divided by 6 is negative 3. I got my two solutions, 4 and negative 3. And I'm good to go. Okay, almost there. 2 more problems. Okay, so with this one, I want to, again, isolate the absolute value. We have 2 things going on over here. So just like we normally would, we want to first get the absolute value expression all by itself. We first undo anything that's being added or subtracted. So that plus 3 is being added. So I would subtract 3 from both sides. So down comes 5 times 2x plus 8 equals 30. 33 minus 3 is 30. We still haven't gotten the absolute value expression all by itself because we have that 5. Now remember, we can't distribute. So to undo that multiplication, I divide both sides through by 5. And I get the absolute value of 2x plus 8 equals 30 divided by 5, which is 6. Now I'm going to continue the problem over here because now that the absolute value expression is isolated, I can start to split it into 2. So that would be 2x plus 8 equals positive 6, and 2x plus 8 equals negative 6. And then we just continue to solve. So I would subtract 8 from both sides. And I get 2x. 8 minus 8 is 0. 6 minus 8 is negative 2. Get x by itself by dividing both sides by 2. And I get x equals negative 1. Do the same side over here. So I want to get x by itself. I subtract 8 from both sides. And I get 2x equals negative 14. Divide both sides by 2. And I get x equals negative 7. So my answers are negative 1 and negative 7. Okay, last problem. So again, I look to see, is my absolute value expression isolated? It's not. So what I want to do is I want to undo this. Remember, we don't distribute, but instead we divide both sides by negative 3. And I get the absolute value of x minus 9 equals negative 7. Now, what do we know about absolute value expressions? We know absolute value expressions should always equal a positive number. And what does this equal? Well, it equals negative 7, which is not a positive number. So when it equals a negative, look above. All of your absolute value expressions before we split them equal to positive. It equaled positive 6. It equaled positive 21. It equals positive 8. So before we split, we have to think, does that make sense? And it doesn't. An absolute value will never equal a negative number. So what this means is there is no solution because an absolute value cannot equal a negative number. And that is it for the study guide. So if you guys have any questions, make sure you guys are bringing them to class so we can review them together. And make sure you do this as many times as it takes to get all of these problems correct. That way, when you come into the test, you are completely prepared and ready to go. Okay, guys, have a great rest of your day, and I will talk to you guys soon. Bye.